Hello friends, Jermaine here and welcome to this video. We're going to be looking at the Riverpod approach to state management in a Flutter application. Riverpod was developed as a successor to the popular Provider library, and it provides a much simpler and intuitive way to manage our Flutter app state. To use Riverpod, we're going to have to install it by running flutter pub add, and I'll install the Flutter Riverpod package. I'll also add the deal package because we're going to be making API calls. Once those are installed, let's come to our main.dart and I'll run this app. And over here we have the standard Flutter app example with this counter value, and we click plus to increment it. Presently, this bootstrapped Flutter application relies on the setState method for updating the state value of this counter. So let's see how we can use Riverpod to manage the state. We'll start by importing Riverpod, and then over here we're going to instantiate a StateProvider. What a StateProvider does is allows us to modify simple values such as integers and strings. In here it takes a callback function which returns our current state value. In order to use this StateProvider, we need a reference to what's known as a ref object, which is an object that allows us to interact with our providers. So let's do that now. Riverpod provides two of its own widgets. One is a consumer widget and the other is a consumer stateful widget, which overrides the createState method that returns a consumer state, like so. And then in our build method, we can retrieve a reference to that state value by doing counter equals, and we want to read the value from our counter provider. So now over here in our column, I'll remove the underscore. And then to actually get the providers to work, we need to wrap my app in what's known as a provider scope widget. Let's restart up. And then we can see over here that our counter value is displayed. We can update this counter value by reading from counterProvider.notifier, and then we do state ++, which will increment our counter's value. So let me save this, and then if I click to increment, the increment happens, but we don't see the change here, which is because we're using the read method. This read operation only runs once, but does not pick up subsequent updates. So we need to use the watch method, which now picks up the update. So if I click that, now it increments like so. And we can get rid of this underscore counter variable. We don't need it anymore. So if we decide that we want to decrement the value of our state, we can copy this one and change it to decrement and make this -. And then let's extend our floating action button by having this in a column. Let's duplicate this like so. And now clicking minus reduces the value of our counter. So just to recap, state providers are useful for modifying simple values such as integers and strings and enums. There are other providers in Riverpod's arsenal that we can use to work with more complex state objects. To demonstrate how we can use Riverpod's other providers, I've created a new folder called Wishlist, which contains a wishlist app.dart file. This file is essentially a consumer widget, which is a stateless widget that exposes the ref object. Effectively, what this wishlist app is going to do is it's going to load some board games from an external API. Then we'll be able to toggle and untoggle whichever board games are our favorites. The API we're going to be working with in particular is Board Game Atlas, which contains a database of board games. So we'll use this API call in particular, and accessing that gives us this response containing a games field, which is a list of game items. What we're going to do is under wishlist, I'll create a file. I'll call it WishlistRepository. We're going to import DO and Flutter Riverpod, and we'll create our repository class. And in here, we'll instantiate our HTTP client like so. And then we'll have a method called getBoardGames, which is responsible for interacting with our API and returning a list of board games. We'll make a GET request to our API/search and limit our results. And then we can retrieve our games JSON data. Now, rather than working with map objects, let's create a model class which would be used instead. Under wishlist, I'll create a new file and then call our model board game. We'll instantiate our board game model class. And for our use case, we only care about the ID and name fields. Let's also create a factory constructor, which will take our map JSON and then instantiate a board game object, pulling in the ID and name fields. Let's export this file. And then let's import that file. So now we can map over our list of games and then convert each map into a board game object. And to use this repository, I'll declare repository provider, and then using Riverpod's standard provider object, we can provide our wishlist repository like so. In order to use our repository provider that we just created, we're going to create a FutureProvider, which is essentially a provider but for asynchronous operations. So under wishlist, let's create a directory called providers, and then I'll create a file called future. And here we'll sort out our imports, and then we'll instantiate our provider. In here, we'll pull in our repository that we created in here. And then we'll return the result of repository.getBoardGames like so. And let's add this to our exports. All right, so in our wishlist app, we can do a ref.watch on our wishlist FutureProvider. And then for the body of our scaffold, we can do wishlist.when. We can listen for 3 states. These are our loading, error, and data states. In our loading state, we'll display a circular progress indicator. Upon any errors, display the error. And then when we have data, we will log out the number of items. All right, and now we're getting operation not permitted because we need to modify our entitlements file to allow client requests. So we duplicate that and we just enter client. I'll do the same for our release.entitlements. And let's run this again by pressing F5. All right, so we got our spinning indicator, and then we get our response with the number of items returned from our endpoint. We can also pass parameters to our providers by using the .family modifier. So that looks like so. With any of our providers, if we add .family, then that means it will take in a second type parameter. And in this case, we'll have string over here. And then in here, we can define that string, which we can pass to our wishlist repository. If I create this constructor here, and then I do client ID like so. And then for our client, I'll do get client, and then we can pass our client ID. And let's not forget to pass the client ID into our repository. I save this, come back to our future example, then pass in our client ID. So this pattern is useful, for instance, if you need to read any values from a configuration file and then pass it to your repository. So it could be an API key. So let's restart this app and it should still work as expected. There we go. And if this request fails, so I'll change this client ID to a wrong one, and then when the request fails, we get our failure message. Future providers are useful for simple use cases, for instance, like loading information from a configuration file. In this scenario, however, we want to be able to retry the query to retrieve the wish list. What that would look like is over here, instead of returning the error text, we'll render a column with text that says problem loading games with a button to try again. So if I save this, then we see the following. With this scenario, it's recommended to use the other providers, which are for more complex use cases. And we're going to look at some of those, starting with the ChangeNotifierProvider. So under providers, I'll create a new file called ChangeNotifier. We'll import the relevant files, and then we're going to instantiate our ChangeNotifierProvider, which returns our ChangeNotifier. Our constructor will require the ref object, and then with the ref object, we can retrieve our repository provider and assign it to this field. Let's create this games field for holding our list of games, and then we'll have our method here called loadGames, which will make the call to retrieve our games. And this consists of making our call, adding our response to our games list, and then we'll invoke this method called notify listeners, which will trigger a rebuild in our widget tree. So I save this and let me export that. And because change notifiers do not have a when method manage the loading state ourselves, we'll have to do something along the lines of, we'll set loading to true by default, and then after this operation is successful, we'll set loading to false before we notify our listeners. And then in here, we will check if our wish list is loading, then we want to render the center or else display the following. And then we'll do wishlist.games.length. So if I save that, okay, so now we only see the loading indicator because we actually need to invoke the method to perform our API call. We'll have to convert this into a consumer stateful widget. We'll have our override, which returns a wishlist app state. And then over here, we'll have the following. Our init state method is where we invoke the method to load our games. And then we need to do widget.title. We don't need this bit because ref is accessible in our consumer state. And let's restart the app. So we see our spinning indicator and then we got our response. And if we want to capture any exceptions, we can do something along the lines of this. So we can create an enum called loading state. Then we can have 3 states, so progress, success, error. And then instead of a boolean, we'll have our loading state. And then we can do loading state.progress. Upon success, we can do loading state.success. And then to capture our error, we need to have this in a try catch. And then in our catch block, we'll have loading state.error. And then we'll notify listeners at the end of it. So then what that means is in our wishlist app, we can check if our loading state is loading state.progress, then we'll show this. Or else if our loading state is error, then we display this text message with a button to try again like we did before, or else we succeeded, which displays this response here. So let's save this and then let's restart. Okay, so we get that and we got a successful response. To demonstrate this error state, let's come to our change notifier and then let's just throw in here. And then after adding this line, let's try this out. Okay, so we get this. To test the try again functionality, I will remove this one over here. Let's add a reload method where we'll set the loading state again, notify our listeners, and then we'll invoke load games. Now wishlist app here, we'll invoke reload games so that when I click try again, see the spinning indicator and then our request succeeds. So change notifiers are essentially the least recommended approach. It's useful when you want mutable state for some reason, but in typical use cases, we could do without using a change notifier, which brings us to the next provider that we're going to be looking at, which is a StateNotifierProvider. Let's create a new file under providers and we'll call it StateNotifier. We'll pull in our relevant imports. And before we instantiate our StateNotifier, we need to define our state. We'll call it wishlist state and we'll mark this with the immutable annotation. Ideally, you should be using a package like freezed. And then we'll manage the following fields, which has our list of games, the items we add to our wish list, and then the loading state. And also because our state is immutable, we'll use this copy with method, which will produce a new state object containing the relevant changes that we've made. And then we'll create our state notifier In here we'll instantiate our API, similar to how we did in our change notifier, and then we'll instantiate our initial state. We will define our load and reload games methods, whereby our load games method will do the following and then update our state with the information. And also let's have this in a try catch. In our catch block, we'll set the error state. And then for reload games, we'll set the relevant state, and then we'll invoke our load games method. And in order to use the state notifier, we need to instantiate our StateNotifierProvider, which accepts two type parameters. The first one is our state notifier, and the second one is our state object. So now in here, we'll return our state notifier object like so, and then let's export this file. Okay, so let's come back to our wishlist app. We'll watch our wishlist StateProvider, and then let's make sure to change this to state, and let's change this to state. And we want the notifier whereby we can invoke the load games method. So let's save this and then let's hot restart. Okay, so we see the spinning indicator and we got our response. And let's make this fail by adding a throw. And let's hot restart. And we got that. And then we'll get rid of that. And let's hit try again. We should invoke reload games. Okay. And then we got our response. Using a state notifier is cleaner than using a ChangeNotifierProvider. And I do like the fact that there is a separation between the state notifier and the state object itself. Another provider, Riverpod, makes available to us that they suggest using instead is a NotifierProvider. Under providers, I'll create a new file and we'll call it notifier. We'll create a wishlist notifier class which extends notifier. Notifier has a which we need to override. So in here is where we initialize our initial state. And then this will be followed by our load games and reload games methods. So we can copy that from here and paste that in here. So the logic is pretty much the same. In order to initialize our API, notifier does expose the ref object. What we can do is have a getter for our wishlist repository, and let's instantiate our NotifierProvider. Alright, so now let's export this. And then in our wishlist app, we'll change all our instances of wishlist StateProvider to wishlist NotifierProvider. So if we save this, and then we restart the app, then we got our response. Although this looks slightly cleaner compared to the state notifier in the sense that we don't need to pass the ref in here, it's already available. We can still improve this a bit further, because if we come to our wishlist app, over here we are still using the ternary operator. It'll be useful and more legible to use the when method that we used earlier with the FutureProvider. So instead of notifier, we can declare an async notifier. We're going to create a new file. I'll call it AsyncNotifier. And then in here, we will copy the contents of notifier in here. And then what we want to do is change our NotifierProvider to AsyncNotifierProvider. We'll rename this as Wishlist Async Notifier. And let's rename this here as well. And then our build method is a future. We can perform the API call here to initialize our state. Can make our load games method private, and then we'll invoke load games. This means that we can simplify the implementation here. So we'll get rid of the try catch wrapper, and then we'll return wishlist state, which will contain our response. And let's be sure to change void to wishlist state. Let's change this one as well to async notifier. Let's comment this bit out for now. We will export our async notifier, and then in our wishlist app, we don't need to invoke this anymore. In fact, we can get rid of that. And then we'll have our async notifier provider. And then in here, like before, we do .when for our loading state, we'll have this progress indicator. Upon encountering an error, we'll display this center. And then when we have data, we will display the following. Let's restart the app again. Let's change this to our AsyncNotifierProvider. Let us look at the reload functionality. Due to the fact that we're using AsyncNotifier, we can replace this loading phase with asyncValue.loading, which saves us from having the loading property on our state. To retry, we can do state equal to asyncValue.guard, and in here we invoke our loadGames method, and we can test it out. If I throw in here, and let's reload, we get this exception as expected. And let me remove that throw. And then when we hit try again, you see the spinning indicator, and then we got our response. We can resume building the rest of our wishlist app. In here, instead of returning the wishlist games length, I'll have this as data, and then we'll render a grid view. Our item count is based on the length of our games. And then in our item builder, we will for now return a card widget. The child will be a text widget, which will output the name of the game. But let's save this. So we got our games. I will make this a variable. Since we're going to be using it a couple more times, I'll adjust the shape and click behavior. And then for our child, we're going to have a stack. And then what we want to display in here, if we go back to the API response, is the image URL of our games. So clicking that will display this one, for instance. So let's modify our model. Which means that over here, we can now render the image in a positioned widget. Let's restart the app. That looks good. Let's adjust the look of this text. Have this text in a container, and then we'll give it a gradient in an align widget. We'll add a style to this text widget, so it looks like that. So let's add the toggle to add a game to our wish list and remove the game from our wish list. And for that, we're going to use an inkwell widget. We'll set the child, and what we want is, once we click on that, it should invoke the method which will add this item to our list. And once it's added, then we should modify this color to red, so it will look like that. Alright, so let's define this method on our async notifier. If we look at our wishlist state again, we're modifying this set. So we'll have a couple of methods. So to add to our wish list, we'll set our state, which will be asyncValue.data. We'll retrieve our current state, and then we'll copy with. In this copy with method, we'll modify our wish list like so. We'll build a new set, retrieving the current items, and then add in our new ID. And for this one, this is more of a helper method to allow us to check our wish list if it contains the game ID. And then removing an item from our wish list is similar to adding, except we remove the ID that we pass in. So let's save that, and then to use this, we can check if it's wishlisted, then we will remove, or else we'll add to our wish list. And then over here, because we have access to our data state over here, we can check if our wish list contains the current game, then we'll render our red accent, or else black 38. So testing this out, if we click on this, there we go, it's been added to our wish list set. And when I click it again, it's removed. So now let's create a screen that will display the items that have been added to our wish list. So down here before the closing scaffold, we'll have a floating action button. And then what we want to do is to read from our wish list, and let's call this state, in fact. So in here we can check the state's value, which will be null while it's been initialized. You can have a ternary here. So if it's null, we'll just have null, or else we'll have a stack. And then in the children of our stack, we'll have a positioned widget, which will launch this method to view our wish list. So let's define that up here. And let's see what that looks like. Okay. And then we'll have another positioned widget which displays the number of items in our wish list. So at the moment it's set to 0. If I click that, now it's 3. If I remove this, then it's back to 2. And when it's 0, we see that. We can make this conditional. So we only want to see this if our wish list set is not empty. So that now hides it. And when it's not empty, now we see it. When it's empty, it's gone. All right, so let's implement our launch wishlisted view. And what that would do is the following. We'll push a new page onto the navigation stack using a slide transition. And then the widget we'll render is a wishlisted view. Let's go ahead and create it. Under view, I'll add a new file, call it wishlisted view. We'll have a consumer widget, and let's add this to our exports. I should deal with that. Okay, so in here, we can also watch our AsyncNotifierProvider, and then we can filter. And then to get our wishlisted items, we are going to map over our wishlist ID set, and for each ID string, and we want the game where the game ID matches our ID. And then for now, I'll print the result to the console. So let's check this one out. Restart. So over here we got the number of items. Let me render a scaffold with an up bar. So now we can render the items in our wish list, and we're going to use a grid view builder. So I'll come over here to our wishlist app and I'll copy all of this and then paste it here. We can make this red like so, since we don't need to check. And also on tapping, we just need to remove from our wish list. And then here we'll do wishlisted. So let's save that. And we got the following. So if we click, that gets removed, that gets removed. And we go back, we see no items are selected. It'd be a good idea to address the scenario where there are no items in our wish list. We can have a ternary for this one. And then we check if it's empty, then we will render the following, which is a column with this text, your wish list is empty, and then a call to action to add some games. If it's not empty, then we'll render our grid view builder. So let me save this. So now we get this. If I click that, that brings us back here. I'll add these items. And let's come back here. All right, and when we remove 2, we see only these 2 are highlighted. And then removing these 2 will give us that. This logic here can actually be moved into a provider. So although providers cache values, providers can also watch other providers and then notify our consumer widget to rebuild this widget tree. We will instantiate a new provider called wishlisted games provider that will return the wishlisted board games. You can have this one here, and we'll have dot value here. So what we'll do is if the state is null, then we'll just return an empty list. If our state is not null, then we can perform this operation here. Now this means that we'll do ref.watch on our wishlisted games provider. Let's do a hot restart and try this. Okay, so I'll add some items. We return to our wish list and we see the items here. If I click this, then we remove the items. If I come back, then we see just 1 over here as expected. And then when I remove that item, our wish list is empty. So as well as the default provider caching values, we can also use that to recalculate values and then use that to rebuild our widget tree so that our logic is a bit more decoupled, assigning the responsibility of these calculated values to these standard provider objects instead. Another useful feature Riverpod offers is being able to use annotations when creating our providers. To demonstrate what that looks like, we'll have to add a couple of packages, which will be the Riverpod annotation, as well as Riverpod generator and build runner as dev dependencies. Adding that means that we can come to this async notifier. We'll import the Riverpod annotation. We'll have a part declaration for our async notifier. So this will be a parts file that will be generated once we invoke build runner in a minute. We can remove this notifier provider, and then we'll use the Riverpod annotation here. And what we want to extend is this type definition called wishlist async notifier, which will be generated shortly. So let's generate that by doing flutter packages, run build runner build. If all goes well, we should see our generated file over here. Okay, there we go. So we got this generated file which instantiates our async notifier provider for us, and then we've got our type def over here, which is an auto dispose async notifier. So what auto dispose does is it will automatically dispose of this object when it's not used anymore. We can remove this import, or save this, and then because we're using the auto dispose async notifier provider, we can do provider.auto dispose, which will get rid of that error. So if I save this and let's restart the app. Okay, and we can add some items to our wish list, and then we can remove the items from our wish list. We can also use an annotation for this one as well. So I'll cut this and then I'll paste that in async notifier over here, and then we can turn this into a standard function. The standard function returns a list of board game objects, and then we'll annotate this. Let's save this, and then let's run the code generator again. Okay, so that should now modify our async notifier with our wishlisted games provider, and let's just call this wishlisted games since it appends provider to the end. And let's run this again. Okay, so now it looks like that. So I'll just save this file, and let's do one more hot restart, and everything should work as expected. Definitely not as expected. We need to cast this ref object to the correct ref, which is wishlisted games ref. That's also generated in this file here. So if we continue and I save this file and then I rebuild, now that we've set the correct ref to what's generated over here, that should resolve it. And there we go. So we'll add some games like so, remove some games, and there we go. Okay, this brings us to the end of the tutorial. If you enjoyed it, be sure to hit like and subscribe to the channel if you haven't already for future tutorials demonstrating how to build full stack applications in Dart and Flutter. And I'll see you in the next one. Thank you.